Good morning. This is Syed Shahabuddin. So you can call me Syed. So today we are going to start a series of videos related to physics. Today we'll start with the plus one. The second chapter of plus one is unit and measurement. Units and measurement. First chapter is theoretical. I think we no need to discuss because it is very easy for all of us to understand. But unit and measurement is very essential and important for all of us to understand the physics clearly. Why? Because without the measurement we can't define the physics. If you want to check the knowledge of someone, you must know what is his knowledge in a subject. He must be able to explain or express in terms of numerical values or data. So those data we can collect by using the different methods what we are going to discuss in the further chapter. So the first thing is we'll start to discuss a very important one, physical quantity. What is a physical quantity? So actually in 6th, 7th or 8th, 9th, 10th we used to discuss physical quantity as a quantity which can be measured directly or indirectly. But here we are adding some more. That is a quantity, a physical quantity in terms of which laws of physics can be explained. And which can be measured directly or indirectly by using different methods. So here let's start to discuss this for few minutes, because a complete understanding about a physical quantity is very essential for all of us. The first thing is a physical quantity in terms of which laws of physics can be explained. A quantity we can say. So with the help of a physical quantity only we can able to explain the laws of physics. We have so many things like law of gravitation. We must use these things, physical quantities, to explain that. For example, if I want to explain so this is well known formula for all of us, law of gravitation, where G is the universal gravitation. G is nothing but universal gravitational constant. So here to explain force, distance, masses, all these things are nothing but physical quantity. If we don't have these quantities like mass, what is a mass? If we don't know what is the distance or length, force, if we don't know these things, it is highly difficult to explain these laws. So with the help of the physical quantities only we are able to explain the physics laws. Then coming to the next one, which can be measured directly or indirectly. So we have so many methods. Directly in sense, for example, if you want to measure the current in a wire, you can plug in the ammeter in a series connection and directly you can find what is the current flowing in the circuit. In the same way, if you want to find something which is not easy to find directly, we can use the indirect method. We have so many methods, further we'll study in the chapter. So indirect method is also one of the method to find out or define the physical quantities. So here how we can express the physical quantity representation. So how we represent the physical quantity. So here physical quantity can be explained or referred in this way, where n is numerical value and u is unit. Again, what is numerical value and what is unit? So we will understand this one with the help of one example. What is the example? We'll take this marker itself. So if you want to know what is the length of this marker, we must measure this. While we are measuring, we use a common scale, 15 centimeter or 30 centimeter scale, which is available for all of us. So while we are comparing, we place side by side and we'll compare. So in this scale we have two things. One is centimeter, and within the centimeter we have 10 more digits. 1 centimeter is equal to 10 millimeters. Within the gap, like for example, zero, 1. So let's assume this is 1 centimeter. So it contains 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is the 10. So 10 millimeter contains in 1 centimeter, it contains 10 millimeter. So with the help of the given scale, we can measure either in centimeter, and the least one, that is nothing but least count we used to call, that is 1 millimeter. With the help of that scale, if you want to measure the least measurement accurately without any mistake, that is 1 millimeter, up to 1 millimeter accurately we can measure. So here let's assume the length of this marker is 10 centimeter or 12 centimeter. Let's assume it's a 12 centimeter. If you write it here 12 centimeter, I can indicate this 12 as numerical value. That means how many times that centimeter is there in this length means 12 times. So here the numerical value represents how many times a centimeter is there in this length. There are 12 centimeters are there. That means a centimeter is in 12 times. So here the numerical value represent how many times the unit present in that measurement. And whereas this is the unit, we can choose as per our convenient. We are using here centimeter, we can't use millimeter. Why? Millimeter is a very small quantity and which is not convenient for us to measure this a huge length. Yes, it is a huge length while comparing to this one. Why? Because millimeter is a very small. If you take a scale, in a scale the least gap between two lines, the gap between two lines, two small lines here indicates millimeter. So here 12 centimeter in sense, what we can write, 12 into 10, so 120 millimeter. So it's a huge number. We no need to represent this one in this huge number. We find a shortcut. If I want to measure the length of your house, what is the convenient unit for us? Meter. If I want to measure the distance between a village to village, a city to city, that is kilometer. So based on the convenience, we choose the unit. So once again, we'll discuss what is a physical quantity. A physical quantity in terms of which in terms of which laws of physics can be explained. As we have discussed, to explain the laws of physics, definitely we need the help of physical quantity, and which can be measured directly or indirectly. As if I want to know what is the length of this marker, I can find directly with the help of common scale available in your geometry box. At the same time, we are not sure that we can measure all the things with the help of direct methods. We use indirect methods, so which we study in the further chapter. So how we represent the physical quantity? This is the exact representation. If you take a physical quantity, this is how we represent. In this, n represents numerical value, and whereas u represents unit. Okay, we are very confused. What is a unit actually? We discussed a physical quantity, but we are not sure what is a unit. Note it down, pause it and note it down once. Okay. Unit. Actually, we choose unit. What is a unit? All the measurement which is standard. See, before we discuss the unit, we must understand what is the essence of standardizing the units. See, if you want to trade in different countries in those days, not now, in those days, in olden days, we are not familiar with the system or the measurement what they were using. In one country, they were using one system, in other country, other system. When they are trading, they got lot of confusion, conflicts due to the confusion in measurement. Let's assume here, if you take a cubit, the length of your hand, a person whose height is 5 feet and the person is whose length is 7 feet, the cubit length is not same. If the 7 feet person want to purchase some clothes from this person, he may measure with his hands. If he measure with the same one, let's assume he want 7 cubit of cloth, and he need a 7 cubit. But the confusion here, the problem is here, he measured with his hand, but whereas to cross check it whether the measurement is right or wrong, he measured with his hand. So he got only 5.5. Now, who is right here? He is also right, he is also right. But there is a confusion. Whose measurement should be considerable? Whose measurement should consider? So to avoid such confusions, we have standardized the things. In the year 1960, they established a bureau called Bureau of Weights and Measures in Paris, where they have standardized the things. So before that, we will discuss what is a unit actually. Okay. Unit of measurement of a physical quantity is the standard reference of the same physical quantity which is used for comparison of the given physical quantity. So actually this line we must emphasize here. Unit of measurement of a physical quantity is the standardized reference. If I want to measure the length of this marker, I must choose the standard reference which is acceptable throughout the world. If in case I mention the length of this marker as 12 centimeter, it must be acceptable throughout the world. If it is not accepted throughout the world, then the length is useless. So I must choose the convenient length. What is that? That is the scale. So I choose the maximum accuracy. So standard reference is nothing but here scale, what we choose to measure. Scale. Of the same physical quantity which is used for comparison of the given physical quantity. So here I must use the standard reference of physical quantity to compare the given physical quantity. Then I can mention the thing that is called unit. Here the centimeter is the convenient unit for us to measure this marker. So I think we have discussed clearly what is a unit. I'll give some example. To measure the diameter of a wire, small thin wire, we use millimeter. To measure the length of a marker, we use centimeter. To measure the length of your house, that is meter. To measure the distance between two cities, that is kilometer. Then here kilometer. If in case the distance, if you want to measure between two planets, that we use as astronomical unit. It is convenient and equal to the average distance from a earth to sun. So how much it is? 1.496 into 10 to the power 11 kilometers. Meters. Ink, 1 second. I'll choose the next marker. So next one is if the distance, if we want to measure the distance from star to star, then we choose light year. That is 9.46 into 10 to the power 12 kilometers, or 9.46 into 10 to the power 15 meters. Both are same. Just we choose the two things, kilometers and meters. If in case the length, if you want to measure far distances more than this, then we use parsec. 1 parsec is equals to 3.26 light year. So everything, the process of choosing the convenient units based on the measurement. If in case smaller than millimeter, for example, if I want to know what is the diameter of a hair, I must choose in micro or less than this. 1 micro, minus sixth of meter. If I want to measure the radius of the diameter of atom, 10 to the power of minus 10. The diameter of nucleus, 10 to the power of minus 15 to 10 to the power of minus 14 meter. So these are very small that we can't able to find out with the help of even a microscope. We must use the latest technologies called such as electronic microscope or very advanced microscopes. So here sometimes this one is actually not possible even with the microscopes. What I am trying to convey you, the unit or the selection of unit is based on the way and the thing what we are measuring. If it is here, it is this. If it is the distance between the planets, then astronomical unit. Based on our convenient, we must choose the units. So we are very sure about the units. Note it down if you want. Pause it and note it down. Okay. Okay. We can change one unit to another unit easily. For example, I must change kilometer per hour to meter per second. Here we must use one physics law that n1 u1 is equals to n2 u2 is equals to n3 u3, sorry, which means the combination of these two must be equal to this. The best example is we have already discussed this. 1 centimeter, here 1 represents the numerical value, that is n, and centimeter represents the unit. So here if you take in CGS system, n, 1 centimeter is equal to 10 millimeter. Here it is n, this is n, and this is unit. So n u, here if the unit what we have selected here is bigger or larger than the second one, automatically numerical value decreases. How? Let's take this to discuss this, to prove this. n1 u1 is equals to n2 u2. Now take n2, this one, this side, u2 by u1. Now select only 1. Now n1 is equals to, I can write 1 by u1. You can see clearly the numerical value is directly, no, it is inversely. Here numerical value is inversely proportional to the unit. If the unit is bigger, then automatically, if it is bigger one, then automatically numerical value decreases. If in case unit is smaller one, then here opposite to this, the numerical value automatically increases. This is what it happens here clearly. We choose a centimeter, that's why we got only 1, and we choose a millimeter, that's why we got here 10 numerical value. So this is how we can convert from one form to another form. So again, in dimensions, by using the dimension, how we can convert, in the topic of dimension analysis, we will discuss that. Okay, I think we are familiar with the two things. The first one is physical quantity and unit. Now, types of physical quantities. Types of physical quantities. There are two types, well known for all of us. The first one is fundamental physical quantity, and the second one is derived physical quantity. So before we discuss derived physical quantity, we must understand what is a fundamental physical quantity. So we'll start with a fundamental physical quantity. So actually any physical quantity which are independent of other physical quantities. Is called fundamental, is called, okay, we'll write, no problem, is called fundamental physical quantity. So if you choose a physical quantity to express the definition or the measurement of that one, we are free of choosing any other physical quantity. We no need of other physical quantity to describe the given physical quantity. It means it is independent. Let's start to discuss the first one, length. To express the length, we no need to bother about other physical quantity. This physical quantity is independent of other physical quantity. What it means? To express the definition of this physical quantity, we are not choosing any other physical quantity. The length is nothing but what? The gap between 2 points. That is the length. That's enough. Whereas if you want to define what is speed, distance by time. Here we have two different physical quantities. That means speed is depending on two physical quantities. If you want to define what is the speed, we must need these two physical quantities. But whereas length is free of this kind of explanation. I think you understood. The next one is mass. What is the unit of this length in SI CGS system? In SI system, it is meter. In CGS, it is centimeter. Next, coming to the mass. What are the systems? We will discuss after this topic. Actually, we must discuss before this, but no problem, we'll discuss after this topic. Mass. Mass is nothing but the amount of matter contained in a body. That's it. We are free to define or use two or more physical quantities. So here we can write simply the amount of matter contained in the body. So the matter, actually this is the term, enough. The mass is nothing but the matter. So to define the mass, we are not using any other physical quantities. That's why it's a fundamental. From there everything starts. And the unit of mass is, in SI, it is kg, and in CGS, it is gram. Now, Again I am giving a small explanation. Fundamental physical quantity is nothing but a physical quantity which are independent of other physical quantities are called fundamental physical quantities. So we are not using to explain the fundamental quantities other physical quantities such as speed, density, volume, so many things are there. So again the third one is very important, time. So we'll discuss after this, no problem. So physical quantities we have discussed, unit we have discussed, types of physical quantities. One is fundamental, one is derived. So in fundamental we are discussing what are its kinds. So what are fundamental quantities? That is length we measured with meter, unit. Here physical quantity and here unit. Okay. That is meter. Second, mass kg. Then third one is time. So how we can define time actually? The gap between two events. Let's assume we have two events. The first event is, there are two events in a classroom itself. When the teacher enters for his period, his class, he entered at 9 o'clock and he left the class at 9:45. So the gap between these two events is nothing but the time period, or in simple terms we can say time. So we can define time is nothing but the gap between two events. We are not using any other physical quantity to define the time. That's why it is fundamental physical quantity. So what is the unit of time? In all the systems we have only second. Next one, temperature. How you can define the temperature? Actually temperature is nothing but the state of an object or body. If you want to define what is the temperature of this body, in definition, very simple. The state, the hotness or coldness of the object defines the temperature. If it is hot, then it having more temperature. If it is cool, then it having less temperature. That's it. So the temperature is nothing but the state of an object, whether it is hot or cold. And we are not using any other physical quantity to define the temperature. Here the temperature Kelvin, or some other places we use theta also. Both the symbols we can use. Next, current. See, current also a physical quantity which we can measure with the help of other things such as ammeter, so many things are there. So ampere, the unit of current. The next one is amount of substance. Amount of substance. Mole. Next, seventh one is intensity of light. That is candela. See, to measure or to define the intensity of light, we are free of using any other physical quantity. Why? Because if take the example of a sunny day and a cloudy day. If you take the days, 2 days, if the day is cloudy, then the intensity of light is less. And if the day is sunny, that means there are no clouds, then we have a sunny day where intensity of light is more. Here intensity in sense in a given area how much light is passing per unit area. So if you use one candle, we have sufficient, that means amount of light around it. But whereas we have replaced with two at the same place, we have much more light than previous one. As we are going to increase the candles, the intensity of light at that place continuously increases. So that is what I am telling you. The intensity of light is nothing but the amount of light in a given area. If you choose here at this point, on this point how much light is falling or passing through, if it is transparent or clear gap. So that is what we can say. These are the 7 fundamental quantities. But here the matter is not end here. The discussion is not end here. As the physics advanced with the time, we need some more quantities which are not included here, but after some time they included in this, which are fundamental only. But those quantities are called supplementary fundamental quantities. Why it is supplementary? Because they added after a long time to this. That's why it's a supplementary fundamental quantities. So those one is plane angle, which is radian unit, and next one is solid angle, stadian. Stadian. We can use stadian as a symbol. Now, what is a plane angle? Very simple. If you take a reference point, this is your reference. Let's assume you have a hand clock at this place. Let's assume this is a 3 o'clock. Actually, the clock moves in this direction. I am taking in this, no problem. Let's assume. When in a given time, if the hand clock swipes some area here, and this is the radius and this is the arc, let's assume, and this is the theta. Don't take watch. If you take anything, whatever it is, angles, in mathematics we are familiar with this phenomena. So in a circle, if this is the radius and it swipes some angle theta in a given time, and the gap from its origin, that means from its initial position to its present position, it called arc. And now if you want to define what is arc here, theta, we can write arc upon radius. This is how we measure radian. The symbol we use theta. We measure theta in radians. While whereas in solid angle we have a 3D. This is 2D. Plane angle is a 2D, but whereas solid angle is a 3D. Let's assume cone. I think we are familiar with the cone ice cream. 3D. Where its sides are concentrated at a one point. Let's assume here. So this is 3D from all the sides. Now this is area. If you want to define, this is R, this is solid angle actually. We can say symbol this is equals to dA by R square, which we use stadian. Stadian. So these are the 9 fundamental quantities. Only 7 are exact fundamental quantities and 2 are supplementary fundamental quantities. Okay, I think you understood this. And this is 3D, not 2D. We have like this also. Cone, complete cone, 3D form. Okay, we'll discuss derived quantities. So any physical quantity which are dependent on other physical quantities. Other physical quantities is called derived physical quantity. So to define a quantity, if we need more than two physical quantities or two fundamental quantities, or in simple terms, don't use this one, any physical quantity which are dependent on other fundamental physical quantities. Replace this one with a fundamental physical quantity. So now we can understand in a better way. See, to define a quantity, a physical quantity, if we need other fundamental physical quantities, such quantities we can say derived quantities. The best example is speed, as we have discussed in a earlier discussion. Speed is nothing but distance upon time. And next, density, mass by volume, volume upon mass. So many things are there. Momentum, what we can say, momentum, mass into velocity. Next, stress, strain, stress, we can say force per unit length, force per unit area, strain, change in length by length. So these things are not only this, so many are there. We have, you can see, take this example, distance is nothing but length, which is a fundamental physical quantity. Time is a fundamental physical quantity. To define this two, to define speed, we must need minimum these two fundamental physical quantity, then only we can define speed. To define density, we need mass, mass is a fundamental physical quantity, and volume, volume is nothing but, again volume we can write, volume is nothing but, what we can write, L into L into L, length into breadth into height, actually H. Length is nothing but length only, breadth also length only, height also length only. So we need these two physical quantities to define density. If we don't have, definitely we can't define the density. So any physical quantity which is depending on fundamental physical quantities can be considered as derived physical quantity. Okay, note it down if you want. Okay, and the next one is let me check whether it is recording or not. Yes, it is recording properly. Okay, systems. So actually, as we have discussed, we got lot of confusion while we are trading from one country to another country between international borders. So we have established a well-known system. Before establishing, we were having three different kinds of systems. The first one is FPS, next CGS, and the third one is MKS. See, after some days, as our necessity increasing continuously, we have standardized this MKS system, upgraded this and standardized. Then it is converted as Standard International System in year 1960. They are keep on revising it as we need accuracy. So here in this foot, pound and second, it is length, mass, time, and CGS centimeter, gram, second. Next MKS meter, kg, second, and SI system is same as it is MKS system, but it is upgraded one. Now you can find one thing in all these three systems. One thing is common: second, second, second. In FPS system, length measured in foot, length measured in centimeter in CGS system, in MKS system in meters. Mass in FPS system we measured in pound, in CGS system gram, in MKS system it is kg. But whereas in all three systems, time we measure in the same unit, that is time, second. So they upgraded in the year 1960 in Paris. So what is meter, what is kg, what is second, everything is mentioned with a very precise one. Why we have measured and defined it? While we are measuring during the experiments, laboratories, industries, so many places. Let's assume I want to manufacture the socket of mobile, which is C-type, and the same C-type headphones I have to manufacture somewhere else. Now the mobile is manufactured in Korea and the headphones are manufacturing in China. Both countries don't have any sort of interaction between each other, let's assume. But the socket must fit to the headphones exactly. If the measurement is not precise and accurate, then definitely they both don't match each other and the product is waste. To get the clarity, wherever it is prepared, wherever it is manufactured, if the length is exactly mentioned and described and defined, then we can avoid confusions and time and loss. So you can see this in textbook. And one more thing, no need to memorize those things. It is not going to ask in the examination. Just for your clarity, they have given in the textbook. What is meter? What is meter? This is. What is kg? They have given. What is second? cesium, this many vibrations, वगैरह, etc. So you need to memorize all those things. Okay, then we'll move for the sum calculation part. Let's assume length. We'll start from the length. See, if you take length, we'll define first how they have categorized the thing. First one, 1 deca, 10 to the power of 1, 1 hecta, 10 square. Next, 1 kilo, 10 cube. Next, deca, hecta, kilo, mega, giga, tera. So before here I must add one thing, angstrom, 10 to the power, sorry, I'm not angstrom in this, 1 tera, 10 to the power 12. Peta. Hexa. Zeta. Zeta. Next. Okay. Eta. So these are called multiples. Multiples. So 10 power of 1, square, cube, power 6, 9, 12, 15. So we have these things. Now if you want to discuss what is ink, we'll see the ink is there. Okay, we use this prefix. These are called prefixes. Now if you use submultiples, so the first one is deci, centi, milli, then micro, 10 to the power minus 6, 5/5 nano, 10 to the power minus 9. Next we have, before that, after that angstrom, we have 10 to the power minus 10, 7, pico, femto, or we used to call Fermi. Both are same. Fermi, 10 to the power minus 15, 9. Atto, 10 to the power minus 18, 10. Same. Zecto, 10 to the power minus 21, 11. Yecto, zepto, that is 10 to the power minus 24. So here these are submultiples. So it is important, better we will, if we memorize this, it helps us in different places. For example, in question they have given a micro, even they will give, for example, a milli meter, something like that. If we want to calculate, definitely we need this kind of numerical values. So definitely we need micro, and one more thing, X-ray, 10 to the power minus 13th. So this is the thing which we have to memorize this. Once you copy and memorize this, don't forget. We'll start from length, how and what are the things are important. This is actually introduction. We have further discussion. So if you take length, as we have discussed, for small thing we use milli. If it is more, meter, kilometer, then light year. What is light year? See, the speed of light or the velocity of light in vacuum is velocity of light in vacuum. Okay, velocity of light in vacuum, especially it is important to mention in vacuum. 3 into 10 to the power of 8 meter per second. In sense, 3 lakh kilometer per second. In 1 second, it can travel 3 lakh kilometers. So this is the known thing for us which have this huge velocity. Nothing can reach to this. But as recently they have proved something else, that proton can travel 1.5 times of light. So yet to be proved properly, because they must have to conduct so many experiments to prove that. So light year is nothing but with its maximum velocity 3 into 10 to the power of 8 meter per second. If it travel for the whole year, how much distance it cover? It indicates the light year. It is approximately 9.46 into 10 to the power of 12 kilometers, or 9.46 into 10 to the power of 15 meters. If it is mentioned in meters, then this is the value, and don't forget. So for long distances, such as the distance between star to star and galaxy to galaxy, the nearest galaxy is Andromeda galaxy. To measure the distance from one galaxy to another galaxy, we mentioned 20,000 light year. For a brief explanation, we'll discuss about what is the diameter of our galaxy. Let's assume this is our galaxy. Our galaxy is spiral, we know. So let's assume this is the diameter. See, if in case today the light start here, to reach other end, it started at one end, to reach other end of the galaxy, it take 1 lakh year. With what velocity? With this velocity. Nothing can reach to this velocity. This is not a normal velocity. This is 3 lakh kilometer per second. That means almost within 1.5 seconds it can reach to, or lesser time, to moon. So to travel from one end to another end, it takes 1 lakh light year. You can imagine how huge it is. To understand the size of our galaxy, definitely we need these kind of units. We can't measure with the help of meters, etc. But here it is mentioned in 10 to the power of 15. You can understand how huge it is. Just for our convenience, we have mentioned in meters and kilometers, but actually it is, these things are very large. Next, parsec. What is parsec? Okay, I will mention here. Parsec is nothing but 3.26 times of light year. If we compress the things into a smaller one, we can memorize it easily. See, these many meters means we may not understand. If simply 3.26 galaxy parsec, so it is convenient unit for us to memorize and understand easily. This is how we measure the length. So many units are there. We'll discuss in the further topic. I think we have discussed nicely. Furthermore, we will discuss in the next session. This is the first session for us. Study well. Keep studying. Thank you.